Hello, everybody. Welcome back to Hawk Tutor. I know I've been gone for a good month at this point, but I was just taking a break, but I'm back, and today we're going to be diving into some organic chemistry, as you can see from the title and from what I have pulled up here. So basically, today we're going to be doing some stereochemistry and RS configurations, and all stereochemistry really is kind of just assigning different configurations to molecules to figure out how they're going to react, and a lot of different things within that. And basically, the configuration that you're going to be assigning is either R or S, as we can see right there, where it's going to be one of those two depending on the format of the molecule. But today we're going to be looking at 2-chlorobutane, which is a pretty common one, and it's also considered pretty challenging. This whole subject is relatively challenging in the organic chemistry field, so make sure to pay attention to Hawk Tutor here and learn up. So anyways, we're going to start off by just looking at the molecule itself, and the first thing you always have to do is define your chiral center. So I'm just going to write that down right there. I really apologize for the handwriting. I haven't done this in a while, but that's just a key term that you got to know right there. That's your chiral center. So basically, in this case, a chiral center, or just in general, to define that, it's always going to be a carbon that's surrounded by 4 different groups. So obviously, in 2-chlorobutane, we have our carbon atom in the middle, surrounded by hydrogen, chlorine. That's an ethyl group right here, and we also have a methane group. So we have those 4 different groups. So we know that we can do a configuration on it, and that we have our chiral center. So now that we have our chiral center, our next step is going to be defining priorities. So obviously we have 4 different groups, so there's going to be 4 different priority levels within this structure. So I'm just going to do 1, 2, 3, 4 right there. And the way that you're going to assign those priorities is based off its atomic number. So to start off, chlorine is going to be our first priority because its atomic number is 17. So that is going to be our first priority there. And next, our next priority is going to be our ethyl group because it has another carbon that's attached to a different one. So we have 2 carbons attaching, 1 and 2. So that's going to be our second priority, and that kind of just puts it right over that methyl group. So we're going to have our ethyl group, and once again, I apologize if I butcher this writing. So next is going to be our methane group because although there's not a carbon attached to another carbon, it's still a higher priority than that hydrogen. So I'm just going to write in our methyl group. And then the hydrogen, it has the lowest atomic number. Therefore, it is going to be our last priority in this case. So next, your next step is going to be basically reorienting the molecule. So in this case, you're going to want that lowest priority. So this one right here, I'm going to circle it. So you want the lowest priority to be facing away from you. So by that, I mean into the page. So it would be that way, away from us. And in this case, we don't even have to do any reorienting because the hydrogen that I'm going to put an arrow to right here is already facing away. So we don't even have to reorient it right there. Our hydrogen is already facing away for us, which is absolutely great. And all right, next things next, we're going to want to trace our priorities. So I'm just going to erase that arrow right there to clear that up. And essentially, you're going to want to go from the highest priority to the lowest priority and trace an arrow around. So in this case, we're going to start at chlorine, and then we're going to go to our ethyl group, and finally go to methane. So we're going to start drawing that arrow. And as we can see, it's going clockwise. So please keep that in mind, that it's going clockwise. And I'm going to define kind of how you can see what's going on right now. And obviously, it's an R or an S configuration, and these are based off Latin root words. But don't worry about that, it's not relevant. So essentially, we have R and S. A good way to remember this is R would be right. So I'll just quickly write it up here. Again, sorry for the bad handwriting. But we're going to write that right up there. No pun intended, of course. But regardless, R would be if it's going clockwise. So once again, I'm just going to draw in clockwise right here. So if it's going clockwise, as it is right here, it's going to be R. And if it's going counterclockwise, I'm not going to write the whole word. But counterclockwise, that says counter. If it's counterclockwise, it's going to be S. But in this case, as we can see, it is completely clockwise. And like I mentioned, you're always going to have to reorient it based on these. It just happened to be that all the priorities were already oriented for us in this way. So essentially, you're just going to look, see that it's clockwise. And yeah, you can kind of just use that to determine it. So follow those steps, and you'll always be able to figure out the RS configuration. And in this case, our final answer is it's going to be R-oriented. So it's going to be R because of, like I mentioned, the clockwise direction of the priorities. So basically, to summarize, you got to find that chiral center. You got to list your priorities based on that atomic number. You got to draw that arrow after reorienting it so that your lowest priority, aka hydrogen here, I'm going to draw that arrow again, is pointing away from you, aka up into the page. And then from there, you draw your arrow and determine if it's clockwise or counterclockwise. Clockwise is going to be R, and like I said, another good way to remember that is just right. So you're going to have R if it's clockwise and S if it's counterclockwise. But thank you for watching if you made it to this point. Hope you learned something. And yeah, that is how you do RS configurations in stereochemistry, which is a part of organic chemistry. So I will see everybody later, but once again, thank you for watching, and goodbye, everybody.